So let's talk about, so once we've either generated a jar file or a nar file or a wheel file or executable Go file, whatever we have, now we have them all packaged. Now we need to actually, submit these to Pulsar so they can be deployed and run. And then we'll talk about the command line and how to do that. And then we'll get into some of the details about how I configure my Pulsar functions, right? Because they're simple, they create the producers and consumers for you, but you might want to change some of those configurations that are available to you through the regular Pulsar client API, right? You want to specify different subscription type, or your schema type, or your user configured properties, or things like that, what your log topic is, things like that, your input topics, all those different ones have to be configured as well. And we'll show you how to do that as well. So after you've packaged your Pulsar function into a deployable artifact, you can use, there's a Pulsar admin CLI tool that allows you, this is the basic way to deploy your functions, and you can deploy them in either cluster mode or local run mode. Now, cluster mode is what you do in production. You submit it up to the Pulsar function cluster, and the cluster hosts that particular Pulsar function, the execution runtime, and he's in the Pulsar cluster is responsible for making sure it stays running. However many parallel instances you have are running. If it dies, it automatically is supposed to restart it. All those different things. All the code executes up in your cloud instance wherever your Pulsar cluster is running. Local run mode is used for debugging. Basically, you're saying I want to run my Pulsar function locally on my desktop machine, but I'm going to still connect to my external Pulsar cluster running somewhere else, right? So it's going to configure, it will still consume messages from your Pulsar cluster in the cloud, but the execution of the Pulsar function code itself is on your local machine. This allows you to set breakpoints and things like that, do debugging, lower level testing, things like that. So there's two options available for your deployment mode inside Pulsar functions. So again, if you want to start a Pulsar function in a standalone environment, you can do this using local run, excuse me, and then you have all these various configuration switches, right? So this is the very basic way of doing it. You're going to, again, Pulsar admin functions is the command, local run is the sub command. You have to specify where your artifact is and give it the fully qualified name. For Java, it's obviously .jar. For Python, it's --py, and for Go, it's --go. So that tells us which artifact it is. You have to give it the class name, fully qualified class name of the main class, the function to execute, so it knows what class to instantiate internally and spin up and run. Inputs is the name of your one or more input topics. You can specify this is the source topic from which I'm going to get messages arrive inside the Pulsar function that the code then gets executed on. And if you specify a return type for your Pulsar function, again, which is optional, you can define it as void. If you don't want to have a return type, you just want to process the messages and not produce any output. That's an option. But if you do specify return type, then you specify your output topic here, and you can only have one output topic, but again, you can have many input topics. And then last but not least, you have to give it a name for management. This is how we store it, catalog it inside Pulsar itself. And this is where we associate state with it. This is where we associate the version and the artifact interface, and that's all defined here. So this is your bare minimum set of requirements. All your default configurations then for your producers and consumers apply. You can look at the documentation for those defaults are, but this is your bare minimum for that. For Python, again, if you created a zip file, for example, then you use a similar command. You do -py, as I mentioned before, pass in the artifact with a zip that contains all of your third-party libraries. And this is showing you a different way, which we're transitioning to the preferred way, which is a configuration file. So best practice is going to be not to have to memorize all these different values and configurations on the command line every time and execute it. You can store that information in a YAML file and associate it with your function so that you can configure this thing and have a lot more control over what sort of properties you want to set. It becomes an artifact in its own right, like your function artifact itself or your class. They should be managed together so you can make changes to one or the other. And this is basically saying, read this YAML file, and all of my configuration information is in there at this point. And this is a best practice. So this is what I'll show going forward. I won't use the command line switches. So the nice segue is this configuration file is used to configure functions. So let's talk about how we configure functions and what some of the different options you have when configuring Pulsar functions. So you can basically break these these configuration options you have down into different categories as shown here. The minimum are obviously the required set of properties that you need. Again, you're going to need the function's fully qualified name, the deployment artifact, what's the name of the artifact that contains the source code you're trying to execute, and also it specifies runtime environment. Again, if you're doing --jar, we know that it's a Java function. Doing -py, we know it's a Python function, etc. Obviously, your input, output topics, things like that. These are the bare minimum things that are required as well. Optionally, again, if you're doing any sort of encryption or decryption messages, you can specify those in their own category. You can further control your consumers and producers with the schema types. And you have specialized serializers, deserializer classes defined, other properties around, so again, such as the various subscription types and policies and names, auto acknowledgements, things like that, producer configurations as well. You can, everything basically it's available in your client API are available here. You can pass them through to create these producers and consumers that are created for you automatically under the covers. There's some resource allocation. Again, these are only honored if you're deploying to Kubernetes. So you can say, I need, this many CPUs. I need, when I'm creating my pod to run this function in, I need this many CPUs. I need this much RAM. I need, this much disk if that's something you want as well. And then when it deploys the pod, it goes out to the scheduler, grabs those resources and makes sure those resources are allocated to the pod running the Pulsar function. And then, as I mentioned before, you can pass in that user config map. We showed in one of those examples in the extended SDK version that there's a way to pass in key value pairs. So if you want to have variable substitution inside your Pulsar functions, then that's a way to pass in however many environment variables you want as well. Lots of different categories on that. And again, there's documentation available in the Pulsar docs around creating these different configuration values. So here's a simple example of a function configuration YAML file. So again, when we're configuring, we say -- my function configuration file or function config file. This is what this content has to look like. You specify the tenant and namespace that the function is going to be running in. Whatever the name of your fully qualified name has to be here. Your input topics, again, this is just showing an example. You can specify them as a list. I can listen to more than one input topic, and this is shown here. This is how you define an array in YAML. Output can only be a single option. Here we're specifying it's a jar file, so again, you can give it the fully qualified name to the jar. Parallelism, how many instances I want running. Resources here. Auto acknowledgement. Do I want to, every time I get a message, I process the message in Pulsar function, you can say I want to automatically acknowledge it versus having to explicitly acknowledge it in the code. And then you can use a user configuration key value map. So just passing key values here. So this is a very simple example of this.